Today I am going to talk about polynomial fitting for delage vapor. So delage vapor is a polynomial that is depend on temperature. So delage vapor we can write as a2 t to the power 2 plus a1t plus a0. So here I have to find out a2, a1 and a0. So for that we must understand the mathematical foundation. So here y is equal to a2x square plus a1x plus a0 plus error. So y is a here polynomial. So y is the dependent variable. So here y is nothing but delage vapor, and x is independent variable, that is temperature, and a2, a1, a0 is the parameters to be determined. Then error minimization. So now here, so y is our observe, and then after fitting the data, after getting that a0, a1, so that will be the predicted y. So if I subtract y minus that predicted, so we'll get error. Then we'll take that square, and I'm adding all this error. So our target should be the minimize the error. So here that s is the error that is depend on a2, a1, a0, that is equal to summation of I is equal to 1 to n yi minus the a2 xi square plus a1 xi plus a0 whole square. So minimize s by setting partial derivative to 0. So dou s by dou a2 is equal to dou s by dou a1 is equal to dou s by dou a0 is equal to 0. So now if I do the partial differentiation, so I'll get three equation. So first equation will get from dou s by dou a2, second equation dou s by dou a1, and third equation dou s by dou a0. So now here three equation I'll get, and we have three unknown, a2, a1 and a0. So now from that equation we can first form the matrix, and if I solve, then I can easily get that three unknown. So here if I write as a matrix form, so this is the matrix representation, and from here I can write matrix as nothing but Ax is equal to B. So A is the coefficient matrix, X is that unknown, A2, A1, A0, and B is the coefficient matrix, sorry, constant matrix. So from that we can, if I solve that that matrix X is equal to A inverse B, so we can easily get A2, A1, A0. Now first we have to calculate X, all this coefficient and constant of that matrix, and then we form the matrix, and then we'll solve. Now for that, here is my problem statement. So for methanol, del vapor varies with temperature as following. So del H vapor is equal to a2t square plus a1t plus a0. So del H vapor is heat of the vaporization kg per mole, T is the temperature, K, and a2, a1, a0 is the parameter to determine. And then here is the experimental data. So different temperatures corresponding to that methanol, that del H vapor is given, the heat of vaporization that is given. So from that we have to calculate a2, a1, a2, a1 and a0. So for that we will use polynomial regression. So we got that matrix, so air matrix. So if I consider that del H vapor is a y and T is a x, so T is a x and the del H vapor is a y, so then, so first we have to calculate all this value, means here, so we have to calculate this, that xi square, xi cube, xi square, all these things. So now here T is our x, okay, so x square, x cube, x to the power 4, and then del H vapor is y, so this is T into del H vapor means Tx, that y xy, and T square, that del H vapor means x square y. So now, so T 298 del H vapor is given, T square you just square that, T cube we have to square that T value, T4 we have to that to the power 4 we'll get that, and T into del H vapor, so we'll get that T into del H vapor, and T square del H vapor, like that we calculate. And after doing all this calculation, so now we have to sum all this, so summation of T, so all that cell value we have to add, that we'll get that. So here we'll get the summation value. Now after getting summation value, so we have corresponding particular value of that matrix means element, so we have to plug that. So like xi to the power 4 summation of that, so here that t to the power 4, so we got this value. Okay, so now we have to plug here. Similarly, that xi cube I we know that t to the power cube, so that is the value, so we have to plug it here. Similarly, so xi square yi means here t square by that del H vapor, so that we got this number, so here we have to plug this number. So now from that, if I plug all this, so we'll get the matrix. Now by using calculator also we can solve that A2, A1, A0, or we can use MATLAB, or you can use different numerical technique. We'll get, if I solve the matrix, we will get A2, A1, A0. Now after solving, we got that A2, A1 and A0 by using matrix inversion. So A2 is minus 0.00184, A1 is 0.0425 and A0 is 51.93. Now after getting that, we can plug it here. So del H vapor is nothing but 0.00184 t square plus 0.0425 t and plus 51.93. Now from here, if I plug any t value, I can easily calculate the del H vapor. Means here I am getting all this coefficient. So now del H vapor is purely function of t. So if I put any t value, I can easily calculate del H vapor. So using that polynomial regression, I can easily find out the coefficient. So that's it for polynomial regression.